gonna add you as co-host if you want to take over screen share.
Yeah, okay. Let me share my screen.
Miriam, welcome, Miriam.
Right. So we are going to start with the week 8, and today we're gonna start with the database concept. And here is the short list of topics that we're targeting to cover. We'll talk about how to create a database, how to make the connection, and some related topic like how to define a table, what is the difference between primary key and foreign key, and the use of constraint. Then we can see how we can insert the data. Then, of course, select the data from the tables, and a little bit about join, maybe update, delete, and a little more, how to connect with pandas, etc. Okay, so I just wanted to jump in here. So, it's part of SQL database. We are trying to see how we can leverage the Python module we already have, which is called SQLite. And SQLite is a kind of like lightweight database, which can be easily set up from Python. And it's a file-based database where you can save the database as a DB file, and we can create tables or do all sorts of database operations. Okay, so first step is to create the database or connect the database. And before even connecting that, we need to make sure the SQLite is installed as a part of the Python package. And the steps are, something similar as we have done for other module. It should be pip install and then SQLite tree. That's how you can install it. So if you look into the connection, how we can make, there are kind of couple of options we have. One is SQLite 3.connect, which will have a direct control, and the cons is we need to close the database or clean up the connection once we are done. And on the other hand, we also have a with SQL 3 connect, which is basically it will take care of the destruction part of it, like closing the database or closing the cursor, those steps. So this is kind of like best practice being used across. And then finally, we know there is like pandas, we can read the SQL. But it is not exactly based on the connection, but it's about like how we can utilize the pandas. Okay. Now let's look into the syntax. The syntax is pretty much straightforward. We can just write like SQL3.connect, and this would be the DB path. DB path means it could be a some file dot DB, and then this will give you the connection. Connection is a object which can be used for executing the connecting the SQLite for our use. Okay, and as you see, once the connection is made, uh, we can use execute command, and then we can create a cursor. This cursor is basically another object which is used for any sorts of operations. If you want to, let's say, fetch the record or execute some select query or maybe insert or update for anything, we need a cursor. So this cursor is basically making sure that you have this cursor connecting to your SQLite database. Okay. Um, okay, before I get into this fetch all and all, I can show you how it looks. I have an example I have created here. So if you see, first step is importing SQLite, and then okay, I have imported pandas for other reason, but the SQLite is the one which needed. And then we can create a connection like this. And then from the connection, we are going to create the cursor. And as I said, this cursor will be used for all the execution, right? So if I run this now, we'll see the students DB, that's the file name or that's the database name I have given. It is being created here. Okay. Any questions so far? Okay, moving along. So once you have the cursor, as I said, we can use the execute method, or there are like bunch of methods like execute, fetch all, or maybe something else. Before even I get into the select, let's look into how we can create the table and how we can insert the data, and then maybe we can come to the selection part. So now let's see how we can create the table. And uh, here I have given the example of a student, for example. And the student database, if we talk about like students database, maybe there are few tables we can assume. There will be student table with student name and age. I'll come to the primary key uh, shortly. And then we can even create a courses. Let's say they have bunch of courses that wanted to register or enrolled. And then finally, the enrollment is another table, and where we have which student is going to enroll and on which course, and finally what grades they're getting in. Okay. Now, if you look into the syntax, it starts with create and then table, then the table name. And within bracket, we can define the name as a text and then passing out a not null to, let me make it a little bigger. So not null is basically saying the text field name cannot accept any null. It should be a value. Okay. And then we also added a student ID, which is basically a auto-incremented field. And what it does, it will automatically create an entry with integer, and this will start from 1. Let's say when you will try to insert first name, first entry of a student, it will automatically create 1 in student ID and followed by the name. And also I added age. Age is again, you need to define the data type of that column. And I added another condition called check if age is greater than 0. Okay, so this is one of the things that we usually maintain where we know that age cannot be, let's say, less than 0, or there are other conditions could be applicable for individual column. We can add part of check.
Real quick,
Okay.
read them.
Yep.
Miriam is asking, what is the role of the auto increment? Is it necessary to add?
Okay. So this auto increment, first of all, will help you to um, refer your table. So when you will start inserting bunch of data into, like, let's say 100 students you have, this will help you, the student ID will help you to tag a number with each name. So for example, you wanted to find some student, let's say Ritam, for example. So when selecting the data, you may not need to know the student name as such, or you may not need to search with the name or age. age anyway, that can be common for many students, but even if the name is unique, there should be something, even if the name is common, there should be something unique to refer a particular student. So by defining an auto increment field, we're trying to add a unique field which can be easily used for such purpose, easily accessible for finding a particular student name. And also there is another advantage of adding a auto incremented column is to add the foreign key. I'll talk about foreign key later, but this will be used as a foreign key as well to map the student name along with other tables. For example, we have enrollment. We can use this ID to map, okay, as a part of foreign key. So this is basically giving you a unique field for students in the table.
You said,
That
thank
makes
you.
sense?
That assigning a unique number to each entry. Got it. Thanks. You are correct. So it's kind of like when we touched last week on primary keys. It's another way that you might hear it referred to.
Right. And also, I probably missed it. So, declaring as a primary key will make sure this is a unique number. There could not be like duplicate in student ID. So that's the purpose of mentioning this table structure as a primary key for student ID column. Okay. All right. So moving along, we similarly have the course table and same syntax. Create table, course name is a table name, and within bracket we are going to define a course ID as a auto incremented primary key, and then course title. And the third table we have is enrollments, and enrollments also have a ID, and then we have another thing called student ID as an integer and course ID as an integer. But before even getting into the insert query, this will basically refer to the same ID that we defined in other tables. So let's say students is a table, course is table, and then in enrollment, we wanted to make sure instead of keeping student name or what like the course he's or she is having, we will mention the student ID and course ID. And from student ID and course ID, we can easily access the other columns that we have in different tables. Okay. And then finally the grade, that's the main column for environment table. And I talked about check. So this is another example where we can check whether the grades are part of these A, B, C, D, F, these characters. If somebody tries to enter something else, it won't allow. Okay, that's a check. And then I was talking about the foreign key, right? So the foreign key comes into picture where we are defining the student ID is a foreign key or it's a reference of students table. Okay, because the student ID is part of the student table where we already defined as a primary key. Okay, so now when we are trying to create the enrollment table, we are trying to say the student ID is nothing but a reference of students table where student ID is one of the field. Okay. And then what it will make sure when you will try to insert a student enrollment data into enrollment tables, it will check whether this ID is a foreign key. If it is a foreign key and reference to a different table, that ID should be there. So for example, I entered my name as Rhythm and the student ID is 1. And when I'm trying to insert my entry into enrollment tables, I should pass this ID as 1. If I pass ID as 2 or 3, something else, it won't allow to insert the data because there is a foreign key added, and it's reference to the um, different table called students, and the student's ID should exist in the student table before even I try to create an enrollment data. So that's the purpose of foreign key. It's a key which is foreign. Foreign means like in a different table.
So you're curious, clarifying that, so a foreign key is a primary key that's on another table. I'll get that concept correct there. So in a relational database, you will have, so we could go back to last week with like the menu, right? So every restaurant will have their menu, but every menu might have the same root beer. So you would not want to write root beer 100 times for your distribution database. You would have the foreign key for root beer that menu for that restaurant would pull to pull root beer into that table. Make sense? Cool. All right.
Okay. So moving along, just let me run it. And then let's look into, so we got the tables created by cursor.execute and with this create statement. And then let's look into how we can insert the data. So these are some sample data. And we're going to use the same cursor object that we created initially. And when you see the insert statement, let's say we are trying to insert multiple record at one statement. And that's where the execute many comes into picture. Okay, because we are dealing with a list of object. If you see this, there is a list defined here. So when we are trying to deal with a list, we need to use execute many. It's trying to insert many records or execute many records at once. And let's look into the syntax. So syntax is pretty straightforward, insert into, and then the table name. And we need to mention what are the parameters we need. In our case, it's name and age. And then values. Values should be having a question mark. That means this is one of the parameter that we are going to pass. And after that, if you put comma followed by the list of data. This is a typical syntax of inserting the data into a table. Okay. And if you have noticed, we didn't pass the student ID here, this field, because student ID is auto-incremented, auto-populated, and I can run and show you how it looks, but that's not needed. It will automatically insert a unique number into a table. Now, for other tables, it's kind of similar. We have course table where we only have one column, that is course ID, and then we are passing, let's say, 3 course for 3 students here. And then also I have added some enrollment data. And if you have noticed, the sequence is kind of like 1, 2, and then 3. This is how we are going to pass along, because we know the auto incremented like numbers will populate like this. Okay, and this is anyway sample data. And then finally, the commit is very important. So once you execute everything, it stays in the cache. We need to run a commit statement. The commit will make sure the data is updated into the database. All right, so let me run it. And let's see how the database looks like. So before getting here, let me just quickly share. There is a extension that you can use to open this kind of file called SQLite Viewer. I'm using this one. There are other extensions as well, but you can try this. And what it will give you once you will open the .db file, it can give you a visual option to check all the tables like this. Okay, so for example, students, I have added student ID is auto incremented, and then I added the name and age, and then we populated the course table and also the enrollment table. And SQLite sequence is probably maintained inside SQL just to maintain the auto incremented sequence number. So this is not, I mean, it is internal. You can ignore. Okay. So once you insert the data, let's look into the select query. Okay, let me jump in here. And okay, I don't know, Hunter, you want to take it from there?
Sure.
All right, I will
All right.
stop.
Let's see. Let me switch my screen. First, I'm just going to cover the why behind, what Redom covered, and thank you, Redom, because that was
Yeah,
exactly
thanks.
what we need to see here. Like, so I know you guys are probably thinking, like, why are we learning this weird, clunky language? Well, when you start building, and if you've done anything in MERN or anything like that, you're going to need relational databases to keep your data. And one of the ways to organize your data into tables that's more universal is to use a SQL-based language. So as you can see, in the relational databases, there are many different ones. There's MySQL, there's SQLite, there's Postgres, which is what I use. And they're all based off of the same structured query language. So just like when you were learning the fundamentals of JavaScript and now that you're learning the Python essentials, you're learning the base, you're learning the base of the C plus languages so that this will transfer into Rust or PHP or anything else that you start to learn because you're going to start seeing the connections together. So let's find a query here. In our query. All right, so now that we've built the database, right? We're going to run all, make sure it all runs. So now with this example, we have the music database because I love doing the music. I think we've got a problem there. And then got our import. So now we're going to start doing queries. So the select statement is the foundation of SQL, right? It's going to be how we retrieve the database from table. And it's pretty standard how you're going to write it. It can get a little long. Like you can add a lot of stuff, as you can see, almost in like a concatenation of keywords. So you're going to start with the select. And why did you do that? Okay. Very much for just throwing me off with that. Let's go back to what it was. All right. So in the select query, you're going to give it its parameters, right? So you have your columns where you want to retrieve it, and then your from is which table you're going to query. Your where is going to be a condition that'll help you filter. That's an optional one. Your order by, that's how you sort the results. And then your limit. So this is very handy when you're working with large data sets. So say when we were talking last week about thousands and thousands of weather data entries, but you only want to see maybe the top 5 for each of the weather stations. This is where you can start doing limits, limiting your rows that are returned so that you're not overflowing everything. That fixed that. Sure did not. All right. So I'll just read it manually. All right, so with the basic select in our database with the artist tables, right, we have the, you're going to, of course, do your path. There's your cursor with the con.cursor with the database that we created. Then you're going to execute. So select mean with the wildcard means all. So we're going to select all from the artist tables, right? And then when we fetch all the results, we're going to store them in the variable results. Results equals cursor dot fetch all. Now we're going to have the column names to help the table that is not going to print for us right now. So we'll move on past that. See if perhaps maybe a different one will run better. There we go. Try this guy. Yeah, so you're running. That must be where the error is. Probably that. Okay. So anyways, there we go. Now we are actually giving it the load. Anyway, so if this was working, what we would get is we would get the artist tables, we would get the length of the results, get the and then the rows in this F string right here. The next print column would give us another F string where columns would be listed over here. And then we have our limit right here. So for row in results, we're going to print row. Ideally, that would have printed right there, but we're going to keep on moving on. So the Pythonic way to do this would be to load it directly into a Pandas DataFrame, which is what we went over 2 weeks ago. I believe we went over DataFrames with you guys. And then, so you're going to load your pandas with the aliases as we set up before with the PD. And then we'll assign everything to the data frame artists. And then we will put the pandas read SQL. And we'll do a select query, all from artists, just like before, this time from our SQL alias as connection, right? So that way we can print the artist as a data frame, which probably is not going to, because no such table artist. So that one didn't run. Maybe, there we go. So now we got our tables working. The other one was just a type. Whatever. All right, so in this one, it's a little example you guys can go through in the group mentor file. So these are some of the join operations. So this is how you can join data from multiple tables. So this is where it gets really handy. So say we're back to the restaurant explanation where you have a distribution and you're got multiple restaurants, multiple menus, and they're all using similar products, similar ingredients. So you could join the matching rows from both tables with the inner join. You can match all the rows from the left table plus the matches from the right table with the left join, or conversely do the same thing with the right join, do all the rows from the right table plus the matches on the left, or do a full outer join, which would bring all rows from both tables into your new data frame, right? So in here, for example, we have our query. It's our select query. So we got the albums.title as the album title. Artist.name is the artist name. Albums.release year, albums.genre. So from albums, this is where the SQL is going to get a little bit longer. We're doing the inner join from the artist on albums with the artist ID, which is going to equal the artist IDs. And then we're going to order them by the albums release year. And then in this data frame, which I'm not even going to press the button on because I'm sure it's going to give me an error message. If we were to print this, theoretically, we would get a data frame that would list the albums with the artist names by the year that we ordered them by. Technically how it should work. Sure it definitely isn't. All right, so multiple joins. If we were doing multiple joins, tracks, albums, and artists, this is when we start adding more joins. And as you can see with SQL, every line you're going to add a little bit more to it. So these can be, I've seen them very long, right? But you can break them down into specific operations. So we're going to be starting with the same query. Now we've got the same tracks.title as the track, albums.title as the album, artist.name assigned as artist. Then we're going to round the tracks duration seconds so that we can get minutes out of it, right? And then from tracks, we're going to do the inner join albums. And with that, we're going to have the tracks and the album ID assigned here. Inner join artists, artist ID. And then we're going to order it by the track duration in descending order, right? So again, if this was working, we would have a data frame with just the tracks full, which would be tracks with album and artist info sorted by the duration. That would give us a nice, easy way to look at this table instead of having to go manually through and look through everything. This would return everything quickly. I'm going to tell this to fix this because
I just wanted to add real quick.
go ahead.
So this is where the primary key is, plays a very critical role. If you see the joinings, these are based on mostly on the IDs, right? The artist ID or, each table, as you have seen, like we probably can add a auto incremented field and that would be unique. And that's why the join I mean, can efficiently use this ID to match or to join multiple tables in your query. So this ID is quite useful in this case.
Exactly. Yeah, because like last week's example, there are many rock bands, but there's only one Led Zeppelin, or at least one famous Led Zeppelin. I'm sure there's like dozens of cover bands, but I'm digressing on that. So you don't want the Beatles albums, if they somehow had an album that was named the same as a Led Zeppelin album, to overwrite the Led Zeppelin album, even though they have similar album names or maybe even lower down on the list, similar track names, because you have the primary key assigned to the artist. That way, that whatever is the children of that is going to be protected by that primary key. That makes sense to everybody? Yep. So then, all right, we have our imports. What's going to work? So maybe the next step will work. All right, so SQLite, this is the one that you guys will probably be using a lot right now because it's free. When you get to like MySQL or some of the other ones, it's not going to be changing a lot different. Maybe some of the functionality will change, but the core functionality and the fundamentals is the same across the board. So in here, we can use a context manager for connections, right? So again, we're assigning this long area as an alias for con, so that way when we do con execute, we're going to make sure we have the foreign keys on here. And then when we execute, we can select the name from the master database. We can get the where type is going to be a table. We're going to have the name, and it's going to be not like equal this, right? And we'll order it by the name. All right, so at the moment, we have no tables in our database, which is because the other ones are broken. But had the other ones been working, we would have saw the artist tracks or whatever tables we had created farther up in this notebook. So this could show you, though, that it did run through and fetch them, even though there's nothing in here for it to fetch. You can see the result right here. So again, the select queries, it looks like we're going back into broken something. Maybe this is just repeating itself. Yeah, let's get down here. All right, so group by. Yeah, we'll go to group by next. So there's the aggregate functions that summarize the data. Group by is one that you're going to use a lot, right? Same with count, uh, average, round, things like this. You're going to, through repetition, you'll become more familiar with them because you're going to use them a lot. So here's a good example that is not going to run either. So with the alias, we have select genre, the count. This is going to be all as number of albums, right? We're going to round the average duration of minutes, and we're going to have that as the average duration. We're going to have the minimum release year as the earliest, maximum release year as the latest. We're going to select that from albums. We're going to group it by the genre, and we're going to order them by number of albums descending. So in this data frame, theoretically, what we would have got is a nice structured table that would have broken that down with the number of albums. It would have given us a count for each genre. It would have given us the average duration and then the minimum and maximum release year. And it would have grouped those by the genre in a descending order. So that's something you guys can play with. And again, this brings us back to some of the very first lessons about imports and how to deal with import errors. So, probably not, but we can try. Give that a moment to refresh. All right, so, and you can combine commands, right? So you can add join plus group by. So again, we run through what we've done. This time we added an inner join with the albums on the album sales by the album ID. Then we have the inner join with the artist or the artist ID. Then we can group them by the albums and order them by the revenue in a descending order. So you can see how building upon these commands can give you a more and more, developed data frame so that your data is evolved better into something that you can present to different groups of people. And then maybe you get too much data back. So you might want to filter groups. This is very handy when you're doing an age group or a revenue group or demographic by a zip code. So again, you can select the format, the count. In this one, we're going to round it as total revenue. So from the album sales, we're grouping by the format, just right here. We're going to have the total revenue greater than 20, and then we're going to order it by total revenue descending order. So it's a couple of little bad practices. You do not want to use F strings. This brings us back to, I think, 2 weeks ago when I was telling you guys about malicious SQL injection attacks. This is one of the most common security vulnerabilities. It's one of the reasons that SQL has so many fail safes and restrictions on it. So you'll see this bad formatting right here. In the F string, we decided to just drop your SQL query in here. So if the user input was drop the table albums, this query would become drop table albums, and this would delete your entire table. And so this is an example of ways that malicious code could be inserted. So like not only could you drop table, but you could drop passwords, you could drop bank account numbers, you could drop things, login IDs, it just goes on and on, like different ways that they have exploited this. So the best practice would be with parameterized queries. So user input rock. With the con, we have the save query. Select the title, the release year from the albums, where genre, right? So in the save query, we take the user input. It's going to pass the parameters as a tuple. So in here, you have the parameter as the user input. You have the query, and then it's going to give you the results. So for title, year, and results, it's going to print the title and the year. So with the parameterized queries, you're controlling the input, right? And so just like with all your other data validation, if the user is providing you some kind of input or some kind of data, it is best practice to make sure you know what he is going to be able to put in, or what you want to make sure they can't put in would be more accurate. Pandas, you can do the same thing. So here you can see an example of using parameters with a Panda read SQL. So in here we have the select query by the title, the release year, the genre from the albums. Where is the genre and the release year greater than whatever it is that we are going to enter, right? And order by the release year. So these little placeholders are saying that I don't have the information for you yet, but I promise you that you're going to get it here very soon so that the operation can run through as you do it. Then when you're printing your genre and your minimum year, it's going to filter it for you in this F string right here by doing, your read SQL. It's going to take your query, from your connection. It's going to have your parameters. So here, this parameter, it's going to be entered, and this parameter is going to be entered, and these placeholders will be filled. So pandas, I know everybody just loves their pandas. Cute, cuddly, great with numbers. So select query. Again, you can see it's going to be using the same SQL language, just set in a little bit different syntax for the pandas, right? And then you got your data frame with your columns, data frame, and we're using the head. So the head does the same thing as when we were doing up there when we were talking about how many rows we wanted returned. It's just a built-in method for pandas data frame. SQL aggregation. So getting a little more complicated, but you can see how if you're manipulating large sums of data. So if you wanted to add the calculated column, this is kind of like if you want to think about like how an Excel spreadsheet adds cells, it's kind of like that. So you're taking the sales where the revenue, the quantity, and you're multiplying it times sales of the unit price, so that'll give you your revenue for each calculation, because this is going to evaluate and get stored into that variable. Then you can group the genre using pandas. You have the genre summary. So that's going to be your data frame of sales grouped by genre. And this is where we're going to do the aggregate, right? So quantity, sum. Revenue is going to be sum mean. Sale ID count, right? And a lot of these terms can get a little bit confusing. I would just say take them one at a time. I'm not going to torture you with matplotlib right now, but you will remember that last week we went over that as a way to do visualizations. So what this would do is just plot out the regional sales in a way that you could present it. It's not going to do. And I listed some practice challenges for y'all, but I know it's the holiday weekend, so just kind of go over some key terms that I want to stick in your brain before I let you guys go for the holiday. So select from table name. Let's remember that the wild card, this is select all, right? So only use that if you really want it to bring you back everything. Otherwise, you're going to want to specify a specific column. So you got column 1, column 2 from the table name. You can filter the rows. So again, you're selecting all from the table name, but where condition adds a filter. So even though you are selecting all, you're still filtering the results. Much better practice. Then you sort the results. So again, even though you're selecting all from this table, you're going to order it by column 1 in descending order. Maybe column 1 is your revenue or your sales. Then same from your results. This is like the method that I showed you in Pandas. So in this one, so we're selecting all from the table, but we're only limiting 10 results. All right, go over inner joins again. I'm up on time here. All right, so inner join, we want to do the matching rows only. So if we're selecting all from table 1, and doing the inner join of table 2 on table 1 ID, then the way to think of this is the foreign ID has to equal the table ID, right? So you're doing whatever matches up in the matching rows. So if you were like, what do these two menus have in common? And you go from table 1, which is menu 1, and they both have, that one has a root beer, and table 2 has a root beer. You can match those up with the joins and be like, all right, both of these restaurants are going to be ordering root beer as a distribution, right? And then again, you can do it with a left join. This is going to be all from the left with the matches on the right. Like say that's your inventory and you want to match that to what this restaurant needs. Instead of having to go in and tell them, I do have that, I don't have that, I do have that, I don't have that. You could just match it up and be like, this is what I have in my inventory that is the stuff that you regularly order. Let's see. Aggregation. So again, group and aggregate, select the category. Here's the count. The sum will be the amount, the average would be the price. So from the table name, we're going to group by the category. And then having the count being greater than 5, right? And then we're going to order by the sum amount in a descending order. And then just to kind of sum up, again, just remember it's very important to do safe connections and parameterized queries because you don't want people thinking that you're trying to do a malicious SQL injection when what you're doing is just trying to learn how to work this. So if you have any other questions, do feel free to drop them in the chat or come off of mute and then read them if you have anything to add to follow up.
No, I think, yeah, you covered a lot. So I would probably request everyone to come up with their questions. So we talked about like how to connect the database, all the basics, like how to create a table, insert a data into it, and a bunch of selections option with all the like additional stuffs like where clause, or it could be, a group by and all the filter conditions and all. So
I will drop
yeah.
this in the chat as like an additional resource for you guys. Because
Yeah,
it
that's
is a
good.
lot to work through, but repetition is really going to be your best bet with this.
Right.
Can you share this file with us? Are you talking about mine right here? After I fix it, I will definitely share it with you guys. So I will push that up in this link in about, give me about 15, 20 minutes to make sure there's no bugs in it. I will add it in the reply with the Zoom link, all right? No problem. All right, guess we'll end a little bit early since it's the holiday. I want to thank you guys for coming in and as Rita always says, you guys have any questions, feel free to Slack us. We'll respond as soon as we can. Y'all enjoy your weekend. Be safe.
Yeah, I echo. Thank you all.